I'm Anshika from BTech CSE 4th semester, and I was assigned with a question from chapter Sequential Circuits. In the question, a sequential circuit is given with three D flip-flops and one input. And in the solution, I have to make state table and state diagrams. But before starting the solution, I tried to explain some of the terms, some of the concepts which are included in the question and in the procedure of solution, and which are important for us to first understand before starting anything, such as sequential circuits, type, what are flip-flops, what are state tables and state diagrams, all these. So I hereby start first with sequential circuits itself. Sequential circuits are nothing but combinational circuits with memory. Now we know that in combinational circuit, the output depend upon present input only. But in sequential circuit, the output depend upon present input as well as present state. Present state represents the information stored in sequential circuit. Present state, if we say, is nothing but actual state of sequential circuit at particular instant of time. With the help of present state and present input, we define output and next state. Now, there are two types of sequential circuits, synchronous and asynchronous. Synchronous are those which run with same clock pulse, for example, flip-flop, and asynchronous are those which run with different clock pulse, for example, latches. Now, flip-flops. I'm explaining flip-flops because clearly in the question a sequential circuit is given with flip-flops and input. So if we say in one line, sequential circuits are single bit storage devices which have two stable states that are used to store binary data, and if we change the input, the stored data can be changed. These are the basic storage elements in sequential logic. Now there are four types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. If we talk about the application of flip-flops, flip-flops are fundamental building blocks of digital electronic systems, which are used in computers, communications, and many other systems. Flip-flops being used in digital electronic circuits such as counters, frequency dividers, shift registers, storage registers, etc. D flip-flop. I'm explaining D flip-flop because uh, we are given with a sequential circuit in which the type of flip-flop given is D, and that's why I have explained flip-flop in previous slide so as to easily explain D flip-flop. As written here, D flip-flop is just the modification of SR flip-flop. We can even design a D flip-flop by SR flip-flop. We just have to take a NOT gate between S and R as written here. SR flip-flop, D flip-flop is likely modification of SR flip-flop by inserting an inverter between S and R. That's what I'm saying, that a D flip-flop can be designed by SR flip-flop by just taking a NOT gate between S and R. If S is equal to 1, the output goes to state 1, and if t is equal to 1, the output goes to state 1, and if t is equal to 0, the output of flip-flop goes to 0 state. In the diagram, Q stands for present state and Q bar stands for next state. D flip-flop is clearly the modified form of SR flip-flop because in D flip-flop we just take the two basic conditions of SR flip-flop, set condition and reset condition, and we neglect the other two conditions that are same output condition and indeterminate output condition. When R is equal to S is equal to 0, output comes out to be same, and we don't feel necessary to include this condition in D flip-flop. And same for R is equal to S is equal to 1, when a condition like a situation like such is created, the output comes out to be indeterminate. It comes out to be indeterminate because the output values comes out to be same for Qn plus 1 and Qn plus 1 complement, which can't be possible because if we say for a variable, a value is coming for a variable x, and for its complement again same value is coming, so this can't be possible. This something is wrong. So indeterminate output comes, and we neglect these two conditions and only consider other two conditions, set and reset condition. Now let me explain state tables and state diagrams. Now the output of the circuit at any time depends upon current state and input, and these also determine the next state of the circuit. The relationship that exists among input, output, present state, next state can be specified by either state table and state diagram. Now state table. In a combinational circuit, we make truth table, but in sequential circuit, we make state table in place of truth table. State table tells us the relationship between present state, next state, and input. And state diagram is just the graphical representation of flip-flops. In addition to graphical symbols, tables, and equation, flip-flop can also be graphically represented, and its graphical representation is known as state diagram. Now this is the question. A sequential circuit has 3 D flip-flops A, B, and C, and one input X. It is described by the following flip-flop input functions as given, and I have to derive the state table for the circuit in first part, and I have to draw two state diagrams, one for x is equal to 0 and other for x is equal to 1 in second part. So this is the solution of first part, state table of the circuit. I have constructed 3 sections labeled present state, input, and next state. Present state designates the state of flip-flop before the occurrence of clock pulse. The next state shows the state of flip-flop after the clock pulse, and the input section lists the value of input variable during present state. And these are the binary numbers of the state. This is the second part of the solution. Two state diagrams are made, one for x is equal to 0 and other for x is equal to 1. This is the graphical representation of flip-flop. Here the circle represents state, and the directed lines, these directed lines these are the directed lines which represent the transition between the state. Yes, the transition between the state. And the binary number written between the circle, these represent the state of each circle. The binary number inside each circle represents the state of the circle. And that's how this works. Thank you.